Hello everyone. Today I am presenting one of my project which is named as Not So Netflix. I have completed this project and this is based on the dataset which was provided by Netflix in the competition named as Netflix Prize Problem. In that competition, everyone was tasked to predict the future ratings of movies by users. The catch in the problem was that there were limited number of ratings and limited number of data set given to us. The data set only consisted of user id, movie id, rating and the date of the rating. This problem is very special because what we were tasked to do is we have to minimize the RMS score which was set by the Netflix own proprietary algorithm which was named as Cinematch. Their RMS score was 0.95 and we were tasked to minimize it by at least 10%, which comes out to be 0.85. The problem to this solution was given by a team named BellKor, and in that team they have proposed a solution which is famously known as BellKor algorithm. In BellKor algorithm, we find a user's latent factor, movies latent factor, users bias, movies bias, and we use everything in a matrix and we factorize the matrix. The problem was that whenever we convert the data given by Netflix into a matrix, it will be a sparse matrix and it was very hard to operate on a sparse matrix. So what I have done is I have implemented that same baseline model from the BellKor algorithm, and on top of that I have implemented LLM, so that user can query to the LLM to find their favorite movie or to find recommendation along with the movie. So firstly let's jump into the implementation of my code. Firstly we will start a Olama server. I have used Mistral 8 billion parameter model. Then we will start our fast API. Here we can see it says table is ready, which means our database is ready. Then we will start our Streamlit server. Now we will query our LLM. What is happening here is whenever a user is firing a query in the chat interface, it will call a fast API, and that API will call the LLMs. LLM will decide if whether it has to use any tool or not. If it has to use any tool, there are certain tools which I have created using LangChain. These tools are recommended tool, search tool, add to cart tool, and checkout tool. Then it based on that it will query the database if it is required to, and it will give the output. Here we can see we got the output such as Monster Inc., Bugs Life, Lion King, Aladdin, and Cinderella, which are pretty similar to Finding Nemo movies, right? Uh, in the in the terminal we can see that it has called a tool. It gets similar movies with arguments as movie name Finding Nemo to get the results. We can also do many things with the help of tools which I have created. Here are chat ideas which we can use to simulate the environment. There are certain things which I have not experimented with, but I would like to experiment with. Here, while I was creating the project while I was creating the project, I thought this project as when you are using Netflix, We when we are using Netflix, we do not we try what I am trying to optimize is we will not jump to the search bar and find the movies. We will firstly jump to the an LLM, tell it what we want, and that LLM will retrieve the movies from the database of Netflix. So I'm trying to simulate that environment. We can also add this Finding Nemo to our cart. Firstly, we will check our cart. Um just as I fired my query, what is in my cart, it will call mm, an tool which is named as view cart with our session ID. The LLM will return the cart for the our session ID is empty. Your see, we can see that the output, your cart is empty. Would you like to add any movies or explore recommendation? We would like to add a movie. Let's go with the Finding Nemo. You might think why I have implemented a cart instead of wishlist. I just want to point out that because in 2007, around when Netflix published this data, there was a different kind of service which Netflix provided, has been added to your cart. Okay, now we will see a view our cart once more. And around that time, Netflix, when we order any movie or when we rent any movie, Netflix used to send a physical DVD to the user to check out to watch that movie, and we are supposed to return that DVD to back to the Netflix. So I am trying to simulate that. Now we can see I have Finding Nemo in my cart. Okay. Also, we can check out based on the story which I have told. I can check out from my cart. So whenever we check out, nothing fancy happens. As I did, as I said, I was experimenting with many things, but I tried to keep it simple and not to make it any complex thing. So whenever we check out, it will simply says your purchase is complete. Finding Nemo has been successfully added to your account. Enjoy the movie. Let me know if you need anything else. We can even get some recommendation from the LLM also. As this LLM is working, like we can see the here is all the movies which LLM is going to recommend. It is printing in the terminal also to see what is happening. Like we can see there are movies which were in the terminal. So this is the project which I have completed. I have used this formula, mu plus bu plus bm plus pu transpose into qm transpose. Here mu is the average, movie average, bu is the user bias, bm is the movie bias, pu is the latent factor of the user, and qm is the latent factor of the movies. Then we find the error. In the error, we will subtract the original rating from the predicted rating, through which we can find the error. What my model achieves 0.94 on the test data, RMS score of 0.94 on the test data, which is already better than what Netflix has proposed at 2007 which was 0.95. So I was happy with that result. So I completed. I stopped my project there. For the curious people, how I have processed my data, I have imported libraries. The most fascinating thing which I have learned is I have used Numba and Ngit. This helped me to compile and train my model very quickly. Then I have converted everything into a CSV Then I have converted that CSV into a matrix. Then taken that matrix and properly implemented into a sparse matrix. Then I have computed mean global mean of movies. Then I have initialized hyperparameters, and then I have initialized parameters. Um, then I have done training. Then I have computed RMSE score. Then I have edited everything into an NPZ format. Now how I am generating the recommendations. To generate recommendation, I have simply used cosine similarity to find similar movies. I have loaded the data from the NumPy. Then I have defined the functions which are used to which we have seen till now. Then everything will be outputted. I'm not running the code right now to save the time. The everything from the pre-processing the data part was done on the Kaggle. Also because I did not have that computational power to run everything and train everything on my on my personal computer. I have trained in it on at 20 epochs. So at 20 epochs, I have achieved 0.9594 RMSE score on test data. On 10 epochs, I have achieved 1.004 RMSE score. So that was all for my project. If you have any doubt, you can know you can mail me, or you can tell me anywhere on LinkedIn, or below in the comment section. Thank you.